All right, let's take a look at scatterplots day 2. We are going to continue to work on estimating values from the line of best fit, drawing in lines of best fit, and determining what the slope means based off of the line of best fit and the context. Okay, so let's do some matching to make sure that we know what types of relationships we have. Okay, so the first thing that I see that this was going down. And if I was to draw a line of best fit, it would be end up going in the negative direction. So that means that is a negative relationship. Okay, that is a negative relationship. The same thing with this next one. I see if I draw a line of best fit, it is going in an upwards direction. So that is a positive line of best fit. And I see that the next one is pretty random. It's kind of all over the place. And if I was to draw a line of best fit, it's pretty hard to draw it. I don't really know where to put it. That one is leaning more towards no relationship because it is scattered all over the place. Okay. All right. Now let's determine whether or not these are good lines of best fit or bad lines of best fit. So, what do you think on the first one? Does that look like a pretty good line of best fit? Not really. That line is not centered in the data. Remember, the job of a line of best fit is to be in the middle. Okay. To be in the middle. So a better line of best fit would probably run somewhere in that direction. Okay. And now I see on the next one, it definitely is not a good line of best fit because it's actually going down and the data is going up. So a better line of best fit would be the second one. This one looks pretty good. That one is splitting the data. So we have, remember, the lines of best fit should be in the middle of the data. It doesn't have to have a single point on it, but it needs to split the data. Okay, let's take a look at some data again, see if we can kind of pull back what we talked about yesterday. So we're looking at the earnings of a food server. We've got hours worked and money earned. So, I mean, logically, you know that the more hours you work, the more money you should make. Okay, the more hours you work, the more money you should make. So if I was to describe the relationship, I see that this is positive because it is increasing. Okay, and my sentence, remember, that is when we're using our labels. So we've got our hours worked and our monies earned. So as I work more hours, or as the hours increase, the money earned increases. Okay, remember, it's always as X happens, Y happens. So independent and dependent. Okay, remember, domain is our X value, so that's our hours, and range is our Y value, which is our money. Okay, all right, let's draw our line of best fit and let's do some estimation here. So let's see. I think I'm going to put my line of best fit kind of right in that area. So I see I've got like 3 above, 2 below. That looks like a pretty good line of best fit to me. I'm going to go ahead and look to see where my y-intercept is, and that is not quite 35. Let's call that a 33. Okay, let's call that a 33. Now, I need some good points for my slope. So I see that I got a pretty good point right here. And I think this is probably a better point than that one. So I'm going to go ahead and use those 2 points. So I see that I'm going from 60 to 80. So I see that's an increase of 20. Remember, these are not counting by ones. I have to pay attention to what I'm counting by. But across is just counting by ones. So that is a 2. So my slope, 20 over 2, well, I know that simplifies to 10 over 1. So my equation would be y equals 10 over 1x, or just 10, plus 33. Okay? All right, so we're going to use our equation, the y equals 10x plus 33, to estimate how many hours the server must work to earn $70. Well, we need to remember that this is the money and this is the hours. So if they're telling me that that's a 70, that means it's going in for the y value. Okay, that's going in for the y value. So I know that to solve that, the first thing I'm going to do is subtract 33. That's gone. 70 minus 33 gives me 37. And if I divide that by 10, it tells me that I really need to work around 3.7 hours. Okay. So let's take a look at our graph. Let's see if that is a reasonable answer. So I need $70. So $70 is right about here. If I come across and I look at kind of where I'm at, I can see that that's pretty close to the 4 hours, and 3.7 is pretty close to 4 hours. So that's a pretty good estimate. Okay, that's a pretty good estimate. All right, now it says about how much did the server earn in 5 hours of work. So again, I'm going to use my equation, y equals 10x plus 33. And I'm going to put, since I'm looking for the total money, this time I don't know this one, I know my hours. I'm going to substitute in my 5 for the x. So 10 times 5 is 50. 50 plus 33 is going to bring me to 83. So I know that I'm going to make approximately $83. Okay, approximately $83. Let's see how close we were. So if I come up the 5 and I come up, I see that's pretty close to 83. That looks like maybe on my line it's kind of looking like 80. But again, remember, this is an estimate. So I should be somewhere between 80 and $83 if I work 5 hours. Okay, so here's another scatter plot. We're going to go ahead and do some estimating and figure out how much gallons of juice cost. And this time we're going to try to use our line to estimate our values. Okay. All right. So let's draw a line of best fit. So let's see. I think my line of best fit probably should run kind of someplace through there. Well, maybe not. Let me try that again. Let's see if we put it. Yeah, maybe something like that. That's a pretty decent line of best fit, I think. Okay, so how much does 1 gallon of juice cost? So 1 gallon. Well, if I take a look at my point, it looks like 1 gallon of juice is approximately, remember, 1 gallon. Do we know how many gallons, how many ounces of juice make up a gallon? So that probably is something we need to know. So take a minute and Google that and tell me how many gallons we need to make, how many ounces are in a gallon. Okay, so that is 128. There's 128 ounces in a gallon. Okay, so 128 ounces, that's going to lead me right over here. Okay, so 108, let's see what we're counting by. So we've got 108 minus our 96. I see that this is going up by 12. So 108 plus 12 is going to run me to 120. And then if I need 128, that's going to put me someplace right in here. Okay, so what would I say that that is approximate cost? So that's going to be, I'm going to say around $10.50 or maybe even $11 because it's pretty close to the middle. Okay, now it says how many fluid ounces of juice can you purchase for $3? Well, $3 is going to run me right here. So I'm going to run kind of in the middle between 12 and 24. So what do we want to say that is? So what's halfway between 12 and 24? Well, 24 minus 12, there's a distance of 12 in there. Okay, we know that. So halfway between 12 and 24 is going to be about 18 ounces. Okay, about 18 ounces. All right, now we've got our line and we have to write our equation. Okay, so we need an M and we need a B. So I think my B for my case, is running right about 2. Okay, it's running right about 2. And my slope, if I'm looking for 2 good points, it looks like I have a pretty good point right there. And I think there's another pretty good point right here. So I'm going to use these 2 for my slope. And I see that I'm going from 6 to 10. So that's a 4. Now this is 12. So I have 1, 2, 3, 4, 5 12s. Okay, I'm going from 60 to the 120. So that's a distance of 60. Okay, so my slope is 4 over 60, which simplifies to, remember to divide that on your calculator and then use that fraction key to do that. And I know that that is actually 1 over 15. Okay, so my equation is y equals 1 over 15 x plus 2. That's my best guess. Okay, my best guess of what my equation is. And again, depending on how you draw your line, your equation might look a little bit different than mine. All right, so I'm using my estimate, my equation, to estimate the cost of 256 fluid ounces. So again, this is my x. So I'm going to substitute in. I have 1 times my 15 times my 256, and I'm going to add 2. So 1 divided by 15 times my 256, that brings me to 17.066666, which I'm going to go ahead and round to 17.07 because this is money. Okay, plus my $2, that's going to run me $19 and approximately 7 cents. Okay, $19.07, which that makes sense because 256 is going to be way out here and my money is going to kind of keep going, and 120 256, that's double. So if it was about 10.50 for a gallon, 256 is actually 2 gallons. It would make sense that that's going to be pretty close to $20. Does the data show a positive, a negative, or no relationship? Well, that is definitely a positive relationship because it is going up. Okay. And if I had to write my sentence to describe, I would say as the ounces increase, the cost increases because they are both going up. All right, so go ahead and spend some time working on your homework. Reach out with questions. Again, make sure that you are looking at the extra videos if you need more support or reaching out to us. We are here to help.